The Milky Way is nothing else but the mass of innumerable stars planted together in clusters by Galileo Galilei. Good afternoon, everyone. Today, we will discuss the chapter 12 entitled The Milky Way. But before that, let me introduce to you the reporters. Christine Ann Onion, Christine Joy Onion, and yours truly, GB Potato. So here's our objectives. At the end of the lesson, the student should be able to: first, describe the Milky Way galaxy. Second, analyze the structure and composition of the Milky Way galaxy. Third, appraise the role of astronomy in everyday life. And lastly, locate the Milky Way bands in the night sky. The Milky Way galaxy is the home of planet Earth and the birthplace of humanity. It is one of the most fascinating scopes of the heavenly bodies. In a clear moonless night, without a magnanimous trace of light pollution, we can see a pale band of light glittering across the sky. It has hundreds of billions of stars, interstellar clouds, stars that are forming, and stars that are dying. It has its own structure, on a scale extremely greater than stars. Since we are part of the Milky Way, it is challenging for us to construct an external view of it. There are still parts of the end of the galaxy that are not observable. However, there have been various approaches which we have identified the size and shape of our galaxy and their place in it. The Milky Way galaxy got its name to the ancient Greeks that the dim celestial glow looked like milk spilled across the night sky, so they called it the Milky Way. This band stretches in a full circle around us in a celestial sphere, but in a different angle from the Earth's equator or the solar system. It is tilted at 60-degree angle with respect to the circle of the Milky Way. This results that we can view the Milky Way at different angles depending on the location where you see it. The shape of the Milky Way. The Milky Way is a spiral galaxy, consisting an enormous dish shape that forms billions of stars. The spiral arms description of the Milky Way shape developed further during the mid-70s, when Thomas Wright, English astronomer, and Immanuel Kant, German philosopher, independently suggested that Milky Way is the flattened swarm of stars. They argued that if the solar system were near the center of spherical cloud of stars. During 1914, science has very little known about the overall shape of our galaxy and their place in it, until Harlow Shapley's indispensable discovery of our place in the galaxy is indeed a remarkable achievement. It began in his study of large groups of stars called globular clusters. Globular clusters is a group of hundreds of thousands of stars, all tightly bound together in a ball of 20 to 100 parsecs across. They have a very distinctive appearance and so are easy to find. By the time he completed his research in 1919, after publishing more than 40 research papers, he is able to convey the overall shape of our galaxy and the position of our own solar system. According to Edwin Hubble's classification system, the Milky Way is a spiral galaxy, although latest mapping studies have evidence that Milky Way holds being a barred spiral galaxy that houses more than 200 billion stars, 100,000 light years in diameter, and our solar system is located about 28,000 light years from the center. We think that the Milky Way galaxy is a spiral galaxy composed of three parts. First is the galactic disk. Most of the stars in the Milky Way are located in a disk about 2 kpc thick and about 40 kpc across. The disk is composed primarily of hot, young stars and contains lots of dust and gas. Stars within the disk orbit the galactic center in roughly circular orbits. The galactic disk is composed of the following. The nucleus. It is the center of the galactic disk. The bulge. The bulge lies around the nuke of the galaxy, including the immediate areas above and below the plane of the disk. It is about 6 kpc across and extends above and below the disk. There is a very little gas or dust. Therefore, the bulge consists mainly of old stars. The spiral arms. These are areas that extend outward from the center. The Milky Way has several arms. The solar system is located in one of the spiral arms of the Milky Way, the Sagittarius. Second is the globular clusters. These are a large group of old stars estimated to be at least 10 billion years old that are symmetrically packed. These globular clusters are scattered above and below the plane of the disk. The stars in the globular clusters are much older stars than those in the galactic disk, and there is a little or no gas and dust present in them. Third, the halo. The halo is primarily made up of globular clusters and is roughly spherical in shape. It is centered on the center of the galaxy and is about 30 to 40 kpc in radius. Likewise, there is a very little dust and gas. The halo is primarily composed of old stars. In lieu of that, most of these stars are low metallicity stars, which means that they have even fewer metals than the Sun.
And for the continuation of our report, let me discuss the topic, the formation of the Milky Way. The Milky Way has the same age as the universe itself. When scientists estimate to be the same age of some of its oldest stars, that is the Milky Way. It is approximately 13 billion years old. This traces back that gravity caused a gigantic cloud of pyramidal gas to fall together and condense. The little clumps inside the cloud collapsed faster than the cloud as a whole and stars formed. This cloud rotated faster and faster as it became smaller and flattened into the present-day spiral disk structure. Stars in the Milky Way. There are absolutely plenty of stars in the Milky Way. There are galactic associates termed as star clusters. Star clusters are bunches of stars located in and around a galaxy. They are groups of stars that form together from a common cloud and in most cases are held together by gravity. There are open clusters and globular clusters. Open clusters contain dozens to thousands of stars, have no particular shapes, and are located in the disk of the Milky Way. Common open clusters span about 30 light years. At their center, stars are highly concentrated, and open clusters typically are too much younger than the globular clusters. These clusters are great for viewing with small telescopes and binoculars, and some of them can be seen through the naked eye. The following are the most famous and can be seen by our naked eyes. And the first one is the Pleiades, or Seven Sisters, located in the northwest corner of Taurus, the bull. It is visible to the naked eye like a tiny dipper. In the Philippine culture, it is known as Moroporo, Mapulon, or Molopolo by the different ethnic groups in the country. Moreover, Christians in our country call it Supot ni Judas or Paunch of Judas or Rosario. It is the 45th object of the Messier catalog or known as M45. And the second one is the Hyades. It is also located in Taurus constellation and it is also a great sight for the naked eye. It includes most of the stars that can be seen in the V shape and the head of Taurus. The Hyades seems much larger than the Pleiades because it is about 150 light years from Earth compared to a faraway Pleiades of 400 light years. Globular clusters are composed of old stars including many red giants and white dwarfs. They appear about as ancient as the galaxy itself. A typical globular star cluster contains 100,000 to a million or more stars that is about 60 to 100 light years in diameter. This dense groupings contains millions of stars which makes them very luminous and can be seen at large distances. It is easy to identify being a globular cluster if it has high degree of concentration at the center and its great number of stars as compared with an open cluster. Another difference is that open clusters are distributed across the galactic disk in a great flat pattern, but globular clusters are arranged spherically at the center of the Milky Way. Most globular clusters are concentrated toward the galactic center. Most prominent globular clusters are the following. The first one is the M13 or Messier 13. It is a globular cluster in the constellation Hercules, representing the mythical character of the same name. The second one is the Omega Centauri. It is located in the constellation Centaurus, the Centaur.
And now, let us proceed to gas and dust in the Milky Way. In the field of view and the outer space, you would notice that there are empty spaces between them. But these spaces are not really empty but contains gas and dust particles that compose the interstellar medium or ISM. This stellar medium has low density. It plays several roles in the Milky Way. One of its most significant roles is that this interstellar gas and dust drives the birth of stars, and the atoms that make up Earth and other bodies came from the ingenuity of the interstellar dust. The dust clouds of the galaxy barely restricted on the plane of the Milky Way. However, a very low density dust can be noticed even near the galactic poles. Approximately 99% of the mass of the ISM is in the form of gas, which is composed of dust. The total mass of the gas and dust in the interstellar medium is about 15% of the total mass of visible matter in the Milky Way. With all the gases in the Milky Way, 90% by mass is composed of hydrogen and other are traces mostly of helium. The gas appears principally in two forms. First is the cold clouds of atomic or molecular hydrogen. The clouds of collomolecular and atomic hydrogen embody the raw material from which stars can be formed in the disk of the galaxy. Second, hot ionized hydrogen near hot young stars. This is created when the ultraviolet radiation emitted abundantly by hot newly formed stars ionizes surrounding clouds of gas. The interstellar matter in the Milky Way is not spread smoothly because the gravity pulls most of it into the thin layer in the disk. In this layer, the gravity and gas pressure cause the gas and dust to clump into clouds, which are embedded in the very low density background gas. Nebula. Nebula is a cloud of gas and dust in space. In astronomy, we define dust as a microscopic solid particles which may be made of silicate rock, ice, carbon, or various combinations of those substances, while gas are maybe in a form of hydrogen, helium, oxygen, nitrogen, and other trace elements. Nebula play an important role in star formation. The following are some of the most important familiar nebula. The gas in the interstellar cloud is sometimes hot and emits visible light. This glowing cloud is called the emission nebula. The young stars of type O and B are the usual power source which cause the gas to light up. They produce ultraviolet radiation, can ionize the hydrogen and other atoms in these clouds. Orion Nebula is a great example of emission nebula. Orion Nebula can be seen using a small telescope or a pair of binoculars upon looking at it. You will notice a fuzzy glow generated glowing in stellar gas adjoining a dense star cluster. If the gas in the interstellar cloud is not hot enough to emit visible light of its own, but dust particles in it may reflect light from a nearby star, which is called reflection nebula. The reflection effect is something like the beams of light can be seen from a coming headlights of a car as it drives through the fog. If the interstellar cloud is cold and sufficiently dense, the dust in it may block the light of background stars and appear as a dark nebula. This type of clouds are too cold to emit visible light, but they emit lower energy radiation at infrared or radio wavelengths. And now, we have here some interstellar molecules and its corresponding chemical formula. First is the molecular hydrogen or H2, hydroxyl radical or OH, cyanogen radical CN, carbon monoxide CO, water H2O, hydrogen cyanide HCN, ammonia NH3, formaldehyde HCOH, acetylene HCCH, formic acid HCOOH, methyl alcohol CH2OH, and last we have ethyl alcohol, which is the CH3CH2OH. Giant molecular clouds are the largest objects in the Milky Way, but they are cold and dark, and scientists would have stared right by them if not for the data gathered by radio telescopes, which can detect emissions of faint radio waves from molecules such as carbon monoxide. Like all other nebula, giant molecular clouds are mostly made of hydrogen, but scientists often study them by means of trace gases such as CO. Planetary nebula are the atmosphere of old stars that started out are typically small. Faint nebula found between the stars as resembling the sun but then expelled their outer atmospheric layers. This ultraviolet light from the hot little stars at their centers, which are all remain of the former stars. These nebula are expanding into space and fading as they grow. Motion of the Milky Way. The Milky Way is moving through space. As the Earth moves around the Sun moves around the Milky Way, as well as the Milky Way moves relative to the cosmic microwave background or CMB, the radiation left over from the Big Bang. It has been measured by the astronomers that our Sun and neighboring stars move around the center of the Milky Way at a speed of about 220 kilometers per second. Due to the vastness of our galaxy, along with all us in the disk, the Sun rotates around the center of the galaxy in response to the gravitational pull of all the material closer in it. Traveling at 220 km per second, it will take 240 million years to complete one orbit. The outer stars rotate too fast to remain bound to the galaxy, but do not spin off from their orbits. This shows that there is an enormous amount of matter providing gravitational attraction for the stars than is observed in the stars and gas, and is evidence for the presence of dark matter. The development of the cosmic distance scale is remarkably from the modern view. The Milky Way galaxy is several tens of kiloparseconds across, and the Sun lies far from the center.